Welcome folks. In this video we are going to look at unit conversion, and this branch of physics is very important because as you are having your tests or exams, you need to know the appropriate unit for a given quantity. For example, we know that we have the standard units, which is the SI units. For example, for distance, we usually follow the meters. So what happens if you are given distance in kilometers or millimeters or centimeters? So you need to change into meters. So the first one, we'll first look at these units that involves distance. Right, so there are some conversions that you need to be familiar with. The first one, we are going to look at 1 kilometer is equal to 1000 meters. So from the word kilometer, there is the prefix, which is the kilo. Kilo means 1000. Now, apart from 1 kilometer, then we know that 1 meter is equal to 100 centimeters. Then 1 centimeter is equal to 10 millimeters. So these are very important whenever you are dealing with distance. Now, for example, let's say we are given a distance of 2.5 kilometers, and the question is maybe we need that distance in meters. So how can we convert the distance from kilometers into meters? So it's what we are going to look at here. Right, so we'll say we need to use the first conversion. So we know that 1 kilometer is equal to 1000 meters. Then this, since it's in kilometers, we are going to put it here where there is a kilometer. So 2.5 kilometers is equal to here. We put x, then we cross multiply. So 1 kilometer x, this will give us kilometers x, then is equal to 2.5 times 1000 will give us 2500 kilometers, then meters. We divide by kilometers, we divide by kilometers, then x is equal to 2500 meters. So to simplify the answer, whenever you are dealing with a calculation and given the distance in kilometers, and if the formula or maybe the principle under that topic requires you to convert the distance from kilometers into meters, the simplest method or principle that you can give is from kilometers to meters, you multiply by 1000. If this is true, then from meters back to kilometers, we are supposed to divide by 1000. So let's see how we can convert now from meters to kilometers. So remember, you use this conversion factor. 1 kilometer is equal to 1000 meters. Then we want to take the 2500 meters back to kilometers. So this time the 2500 meters will be where there is meter. Then here we put x, we cross multiply. So 1000 meters times x is 1000 meters. X is equal to 2500 meters by kilometers. Then we divide by 1000 meters, also here by 1000 meters. So this is just the way of showing our working. So if we divide by 1000, this will give us 2.5 kilometers. So we can now simplify what we've looked at like this. So we can say 1 kilometer is equal to 1000 meters. Then from kilometer to meters, you multiply by 1000. Then the reverse, you divide by 1000. Right, so for example, whenever you are dealing with the, let's say, formula under the acceleration, for example, if we're using with this formula, displacement is equal to initial times time plus half acceleration multiplied by t squared. So the s represents the displacement or distance provided it is in a straight line. So if I'm given the distance in kilometers, for me to use this formula, I need to make sure that the distance that I'm using must be in meters, right? So now let's say we are given some units. For example, we want to convert 500 kilometers. Then this time we want to change this, let's say, into millimeters. So how can we convert kilometers to millimeters? So there are two ways in which we can do this. We can first move from kilometer to meters to centimeters, then to millimeters, or if you want we can just go direct. So let's check this. So from kilometer to meter, remember you multiply by 1,000. Then from meter to centimeter you multiply by 100. Then from centimeter to meters you multiply by 10. So if you want to move from kilometer direct to millimeters, then this will be 1,000 multiplied by 100 multiplied by 10, which is this one is giving us same as 1 million. So we can now make the conversion factor where we can say 1 kilometer is equivalent to 1 million millimeters, so that I can put my 500 kilometers on the left side, then here we put x, we cross multiply. So we have kilometer x is equal to, so this time we are going to have 500 million kilometer millimeters. Then we divide by kilometers, also here by kilometers, so that if we cancel this, we will have 500 million millimeters. So this is what we can do. So this is about the distance conversion. Now let's move away from the distance. Let's say we want to look at the mass this time. So mass is defined as the total amount of matter occupied by a substance. Now for mass, we'll just look at 1 kg is equivalent to 1,000 grams because of the prefix kilo. Remember, kilo represents 1,000. Then what else can we look at? We can also look at 1 ton. So 1 ton or 1 metric ton is equal to 1,000 kilograms. Then 1 gram is equal to should be 1,000 milligrams. So with this excuse me, how can we convert 25 kilograms into grams? For example, let's say you are told to find density, and we know that density is equal to mass divided by volume. So let's say the volume given is in cubic centimeters. If the volume is in cubic centimeters, then the mass must be in grams. So how can you convert these kilograms into grams so that the units are able to match? So this is what we are going to do. So we use this conversion, which is 1 kilogram is equal to 1,000 grams. Then 25 kg will be here. Then here we put x, we cross multiply. So this will give us kilograms. X is equal to 25,000 grams per kg. I mean kg. Then we divide by kg. We divide by kg. So x is equal to 25,000 grams. So if you look at the sack of meal is given the one for 25 kilograms is same as 25,000 in grams. So to simplify our answer, we can say 1 kilogram is equal to 1,000 grams. So if we are moving from kilograms to grams, you multiply with 1,000, then the reverse, you divide by 1,000. So that's the principle. Okay, now maybe let's say we want to convert the mass given in grams. Now we want to make sure that we convert that one to kilograms. For example, whenever you are calculating potential energy is given by mass multiplied by gravity times the height. So make sure that the mass is in kilograms. So what happens if you are given mass in grams? So we need to change. So to show our workings, we said from grams to kilograms, we divide by 1,000. But how can we show these workings? So say 1 kilograms is equal to 1,000 grams. Then our task is we want to convert 500 grams. So the 500 grams will be here. Then we put x, we cross multiply. So this will give us 1,000 grams. X is equal to 500 grams multiplied by kilograms. Divide by 1,000 grams. Also here by 1,000 grams. Then x is equal to, we cancel this. So we know that 1,000 into 500 is 0.5 kilograms. So this is just the showing of workings. Away from this, let's look at time. Time is also important. If you look at, if you are calculating about acceleration, the time should be in seconds. Time under pendulum in seconds. Then if you look at, if you are trying to find the cosine under the electricity, the time should be in hours. So you need to know how to convert from seconds to hours and also the reverse. So begin with 1 hour is equivalent to 60 minutes. Then 1 minute is equivalent to 60 seconds. Then we can also add in terms of a day. 1 day is equal to 24 hours. Now for this one, we'll look at, we'll use this one in terms of converting the distances. If you are looking at, for example, given speed in kilometers, then 2 meters per second. So let's say we have been given speed in kilometers per hour. Then for us to use the given formula, we need to use the distance in meters and the time in seconds. So say meters per second. So the point is, how can we convert, or how do we convert speed in kilometers per hour to meters per second? So this is what we are going to look at. So let's have an example. So let's say we have been given the speed of 40 kilometers per hour. So this means that for every 1 hour, a distance of 40 kilometers is covered. Now here we are going to write it like this. So we'll say 40 kilometers then over hour. So remember, we've looked at the conversion from kilometer to meters. So we said you multiply by 1,000. So on top, the number that you are given on top, you multiply by 1,000. Then for hour, how can we convert hour into second, or how many seconds makes up an hour? So remember, 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So 60 times 60 will give us 3,600. So 1 hour is equivalent to 3,600. So in order to summarize what we are looking at, what we are looking for, whenever you are converting from kilometer per hour to meters per second, you multiply the given speed by 1,000, then divided by 3,600. So this will give us 40,000 over 3,600. So we can now do the math. 40,000 divided by 3,600. So I'm getting about 11.1, say, meters per second, which means that in 1 second, 11.1 meter is covered. So this is how you should deal with that. Now let's say we want to now do the reverse. How can we convert 24 meters per second into kilometers per hour? So how do we deal with this one? So for this one, we just have to reverse. So we are just going to reciprocate this here. So the 36 will be on top, then over 1,000. So whenever the 1,000 is on the denominator part, then 3,600 is on the numerator part, you are converting from meters to kilometers. So say 24 multiplied by 3,600, I'm getting 86,400 over 1,000. Then my calculations, I'm getting 86.4. So this is in kilometers per hour. So remember, from meters to kilometers per hour, you multiply by 3,600 divided by this 1,000. Then from kilometers to meters per second, you multiply by 1,000, then divided by 3,600. Or if you want, you can just commit this point to memory. So let's say we want to convert the same 40 kilometers into meters per second. So what number can we multiply this? So remember, let's do the math here. Is 1,000 over 3,600. So I'm getting 0.2777, which is 8. So if you want, you can just commit this number. So any given speed in kilometers per hour times 0.28 will give you the answer that we want. So let's say 40 multiplied by 0.28. So I'm getting about 12.2. Now the reason why here is because of I've just round off the number, but we can see that we are almost there. Then for the other one, 24 meters per second, if I want to change this number direct into kilometers per hour, I can multiply by 3.6. So 24 times 3.6, I'm getting 86.4, which is the same as. Now where are we getting this number? Remember, we said is 3,600 over 1,000. So if you do the division, you cancel this. 10 into 36 is 3.6. So for you to move direct from meters into kilometers per hour, you can multiply by 3.6 or 3,600 divided by 1,000. You get the same answer. Then we need to look at some prefixes with what they represent. So the first one is tera. Tera is equal to 10 raised to the power 12. Then we have giga. So giga, like from the GB, gigabytes. So this is 10 raised to the power 9. Then we have mega. Mega is 10 raised to the power 6. We also have now kilo. Remember, we looked at this one. Is 10 raised to the power 3. Then we have hexa, which is 10 raised to the power 2. Then deca, which is 10 raised to the power 1. Then from there, we can now look at where we have 0 point something. Like the first one is deci, with 10 raised to the power negative 1. This number is same as 0.1, so don't forget this. Then we have centi, with 10 raised to the power negative 2. Then we have milli, 10 raised to the power negative 3. Then we also have micro, from the word micrometer. I mean, not necessarily micrometer, but the prefix micro. So micro simply means a very small number. So micro is 10 raised to the power negative 6. Then we have nona with 10 raised to the power negative 9. Then we also have pico with 10 raised to the power negative 12. So you need to find ways of how you are going to commit these into memory, because for some of the questions from section A of science paper 1, which is physics, requires maybe for you to remember one of these. You may be given, from the given multiple choices, which number is representing a mega. So you may be taught a mega. And the other thing, not only you need also to know how can you write this number 10 to the power 12. What is this number in terms of in its expanded form? So in its expanded form, it means we need to write it like this. So this is what this number represents. What of this one? This is 1,000. Okay, so that's what we can look at. Then to summarize what we were looking at here, we are looking at units conversion. For example, if you are looking at calculations maybe under electricity, you may be given 2 kilowatts. But see, for example, if you are using the formula power is equal to voltage times current, the power should always be in watts. So this means that if you are given the power in kilowatts, first convert to watts for you to get the actual value. Then sometimes you may be given 1,000 watts and you are told to calculate the cost. So cost per unit is equal to, cost is equal to cost per unit. Then power should always be in kilowatts. So if you are given watts and told to find the cost, you are supposed to convert into kilowatts. So how do you do? So just remember, here we have a kilo. It means 1 kilowatts is equal to 1,000 watts. So this is the conversion factor that you are supposed to do. You can also look at kilopascal. We have kilohertz, stuff like so. Whenever you see a kilo, it means there is 1,000 of that. So this is what we can share for this video. Thanks for watching.